Hello everyone, welcome to this new lecture of Basics of Civil and Mechanical Engineering. My name is Professor Mohammad Amiruddin, working as an assistant professor in Department of Civil Engineering from Anjuman College of Engineering and Technology, Nagpur. This is not the first lecture of Basics of Civil and Mechanical Engineering. We have already took the first lecture which was on Google Meet, and in previous lecture I told you about this subject. Today I'll repeat those things. Uh, this subject, Basics of Civil and Mechanical Engineering, consists of 6 units. Okay, the first 3 units, unit number 1, 2, 3, is totally based on civil engineering, basics of civil engineering, and the other three, that is unit number 4, 5, and 6, is based on mechanical engineering. I will teach you about the basics of civil engineering. Okay, I will teach the first 3 units, and in previous lecture, around 37 or 38 students were there, and we have discussed the basic introduction of this subject. Okay, civil engineering, basics of civil engineering. We have discussed the basic introduction, and I also told you that the next lecture will be on YouTube. Okay, and today I will start with the basic introduction again. Okay, those who missed that lecture, you can cover here. In previous lecture, I told you that this subject will not have an university exam. Okay, this subject will not have an university exam. The assessment of this subject will be totally internal. Totally internal means the teachers will give the marks on the basis of the students' performance. Okay, they will uh, they will judge on the different basis. For example, maybe unit test will be there. Okay, attendance, or the other parameters, for example assignments. Okay, so the judgment will be on the basis of these parameters. Students will get marks out of 50. Okay, so subject will be based on 50 marks. Okay, so the first 25 will be on civil engineering, the next 25 will be on mechanical engineering. So let's get started. I'll repeat those things again, so listen carefully. Okay, so let's start with the basics of civil engineering. Okay, in previous lecture I told you about these topics. Okay, introduction to civil engineering. Today we will study introduction, broad disciplines of civil engineering, scope of civil engineering, role of civil engineering in infrastructure development, and importance of civil engineering. We will try to cover these topics. Okay, so first is the introduction, the subject introduction. Civil engineering, what is civil engineering? Okay, let's see what is civil engineering basically is. See, see, civil engineering is the oldest branch of engineering which is growing right from the Stone Age civilization. Okay, why civil engineering is the oldest branch? Because if you compare this branch with the other branch such as CS, mechanical, electrical, okay, what came first? Civil works. Okay, how? Because if you think about the people from Stone Age or after that, they used to construct their own houses. Okay, they used to construct their own houses with different materials. Okay, they use stones, okay, tree leaves, maybe wood, okay, maybe bamboo. They use different materials for constructing their houses. Okay, that's why it is called the oldest branch. Okay, the oldest branch of engineering. Okay, that's why it is called as oldest branch, because right from the Stone Age civilization people used to construct their houses with different materials, and as the time passes the material changes, the improvement, material also improves. Okay, people used to construct their houses with different materials. For example, before coming before for example, if you consider the roofs. Okay, in Stone Age, people may used, I think, maybe tree leaves, bamboo, wood material. In today's time, or we used flat slab, for example, concrete slabs. Okay, GI sheets. There are different tiles are also used to cover the houses. So the material also changes with the time. Okay, today we used bricks for wall construction, but when bricks were not there, people used to construct their houses with wood material. Okay, wood material or bamboo. So the material also changes. That's why it is called as the oldest branch. Okay, it is the oldest branch. And if you think the word civil, what is the meaning of word civil? Meaning of civil is ordinary things. Okay, in case of ordinary, I would say the common things. Okay, in case of instead of using civil meaning that is ordinary, I will use common things. For example, what is common things? Common things are which you see on a daily basis. For example, you live in your house, that is constructed by civil engineer. Okay, you use roads, that is constructed by civil engineer. Okay, then you come to college, that is also constructed by civil engineering. Okay, civil engineer. Then bridges, canals, dams, tunnels, large multi-stories buildings. So these multi-storied buildings, tunnels, bridges, these are the civil works. And I told you civil means common, okay, or you can say ordinary things, common things which you see on a daily basis. Okay, so that is the meaning of civil. That's why civil engineering is the very common and the oldest branch of engineering. Because without civil engineering we cannot live. Okay, first is what is basically civil engineering involves. It involves planning, after planning design, then construction, then maintenance of structures. Okay, first is you have to plan, after planning you have to do design, after designing you have to construct those things, and after constructing your work is not over. You have to maintain that thing in a particular manner, in a uh, proper manner. That's why maintenance of structures is also very important. Now, what kind of a structures you will plan, design, construct and maintain? That structures are Such structures are bridges. Okay, bridges, that may be railway bridge, road bridge. Okay, after that roads. Okay, canals. Now canals is the small you can say the okay, canals are waterway channels. Okay, that is nothing but artificial waterways, for water conveyance, to transport water from one place to another place. Okay, these are called as canals. Okay, these are largely used in irrigation engineering. Canals is very important in irrigation engineering. That is also constructed by civil engineer, mostly used for irrigation engineering. Okay, after canal, dams. Okay, you might have seen dams. Okay, it's a common thing, dams. Tunnels. Okay, while traveling with on train or road, you see passages constructed below the hill. Okay, a passage is constructed, that is called as tunnel, by cutting hills. Okay, that is called as tunnels. And then multi-storied building, then more than one story, 2 floor, 3 floor, 5 floor, 6 floor, 7 floor, these are called as multi-storied building. Okay, for example, if your house is of 1 floor, you will say one story. Okay, like this. So multi-storied building, when you have more than one story. Okay, that is called as multi-storied building. So it involves planning. For example, suppose I'll give you an example. For example, you became a civil engineer and someone told you that he wants to make his house. So first thing, what you will do, you will not go to the site and start constructing his house. No. Okay, first thing, remember, you have to plan that. You have to plan how would you proceed. So first thing would be, what should be the uh, plan of the house. Okay, for example, let me just draw the small plan of a particular house, just for your understanding. I'll give you an example how planning, construction and design involves in civil engineering. Suppose this is the plan of your house. Now what is the plan? Plan is nothing but the top view of your house. Okay, for example, if you remove the slab of your house and if you look from the top, your house will look like this. Okay, this might be the hall, this might be the staircase portion, this might be the bedroom, this might be the kitchen. Okay, so different rooms will be there. So for example, if you got the contract of constructing a house, first thing you will do, you will plan these things. Okay, you will plan which room will be located on which side. Okay, you will plan, this is called as planning. Okay, you will plan the front elevation, how the house will look from the front, look from the side, look from the back. Okay, so this is called as planning work. Okay, I'm just giving you an example, this is called as planning work. In planning work also, you will find out what would be the cost of construction, how much would be the estimated cost. You will tell the client that your house will take around 20 lakh, 30 lakh, whatever the cost, you will find out. Okay, so your work is to plan. You have to arrange these rooms. After arranging these rooms, you have to also identify what should be the approximate cost of of the construction of this house. Okay, so these locations of room or planning, what should be, where the bedroom will be there, where the kitchen should be located, so this is called as planning work. I'm just giving an example. Okay, so planning, this part planning. Okay, first thing you have to do planning. Okay, after planning these things, you will move to the next step, that is called as design. Now many of you would think, what is the difference between planning and design? In civil engineering, planning and design are the two completely different. Okay, different parts. First, planning means you have to plan those things on paper. Okay, and in design, what you will do, you will design the structural elements. Now for example, uh, you have seen columns. Okay, you might have seen columns generally in your house, you know what is column is. Then beams. Okay, then slabs. Okay, column, beam, slab, foundation, these are all called as structural elements. Okay, if you I give you an example. So for example, suppose these are the beams, these are the columns. Okay, and this is the slab. Okay, so this how the load is transferred here, what is the basically design means. For example, this is a slab transfer the load to the beams. Okay, beams are the horizontal members. Okay, after that beam transfers the same load to the column. Okay, then beam transfer that load to the column, and then column took this load to the ground. Okay, they transfer this load to the ground. So these are the structural elements: slab, beams, which is the horizontal member. Okay, you know what is slab is, and beam is the horizontal member, and the columns are the vertical members. So the load transmission starts from the slab to beam, beam to column, and then column took those loads to the foundation level under the ground. Okay, so while transferring these loads, the structure elements also carries those loads. That's why we have to design those elements. Okay, okay, they have to carry these loads and then transfer it. So while transferring it, these structural elements may fail if you don't design it properly. Now design means giving these structural element proper size. Okay, what should be the thickness of slab, what should be the size of beam. Okay, what should be the size of beam. Okay, what should be the thickness of beam. Okay, and what should be the thickness of column, the width. Okay, the depth of column. These structural element, design of these structural elements is called as design. Okay, okay, so in this design you have to also identify, you have to also find out how much should be the reinforcement should be there, how much steel should be provided. Okay, these all this process comes under the design part. Similarly, in case of bridges also, in case of dams also, you have to design those structural elements. After planning, the next step is design. That's why you have to design these things. Okay, for example, suppose this is the section of a column, okay. So this is the width, this might be the depth, and height is different thing. You have to identify what should be the width, what should be the depth, how much reinforcement should be there. So these are the part of design element. I hope you understood this. After designing those structural elements, after designing slab, concrete, slab, beams, columns, the next step is construction. That is also very important. Construction, or you can say execution. So next step is construction, which took place in site. Okay, the actual site, the site engineer performs those construction things, and you have to, this thing. One thing also you have to remember: whatever things you have planned, design, the construction should be similar to those things. Okay. For example, you have given the size, suppose column size of 230 by 300 mm. So in actual site, it should be 230 by 300. Okay. The size should not change. The bars, reinforcement, number of bars, number of steel bars, whatever you have designed, it should be similar to the actual construction. So after construction, one thing is also important, that is maintenance part. Because if you don't maintain those structures, especially in case of public buildings like the big offices, and also in case of bridges, the maintenance is very important. In case of dams also, maintenance of those structures is very important. You have to frequently check, okay, the stability, the condition of structure, that is called as maintenance. For example, if you find out that there is a small crack, okay, so you have to uh, fill those gaps, fill those cracks with the different materials. You have to repair those things. That is the part of maintenance, so that is also very important. So I hope you understood this first passage. Okay, this first passage, what is civil engineering and what actually civil engineering involves, that is planning, design, construction and maintenance of structures such as bridge, road, canals, dams, tunnels, multi-story buildings. Okay. Next is civil engineering is a profession in which knowledge of the mathematical and physical science gained by the study, experience and practical practice is applied with a judgment to develop ways to utilize economically the material of the progressive well-being of man. One thing, remember this thing, that the role of civil engineer is to give a design which is economical. Okay. For example, if you again see the example of this house, for example, this is the plan. Okay. For example, as a civil engineer, you will think that always you will always think about the two major points. Okay. The two major points while constructing, first is the safety and the next is the economy. Now, safety is the prime thing. Okay. The the and the preference should be given to the safety first, after safety, economy. But that is the most important role of civil engineer. He has to design the structure safe as well as economical also. That is the most important thing. For example, you have to as a civil engineer, you will try to think that whether the cost should be reduced, on which part I can reduce the cost as much as possible. But safety should be given the first priority. We cannot neglect the safety part. Safety part always comes first. Okay. For example, again I'll tell you that, for example, this is the column section. Okay. And you have given the size, for example, a square size column of 500 by 500, for example. Okay. And 500 by 500. Okay. And you think that, okay, this 500 by 500 is might be the large size, and it may affect the economy. Okay, it may affect the economy. The cost of construction may increase because of the large size of this column. Okay. But suppose the load is very heavy on this column. The load is very heavy on this column. So the requirement of the size is 500 by 500, and load is also very heavy. So what you will do, you will give the first preference to safety. You have to maintain that size 500 by 500. You don't think about the cost. Safety always comes first for a civil engineer. After that, economy is very important. Okay. So the most important uh, object or most important duty of a civil engineer is to give economical as well as safe design. Okay, let's move. Okay, I hope you understood these things. Next is the broad discipline of civil engineer. These are the various branches of civil engineering. Okay, first is surveying, construction technology, structural engineering, geotechnical engineering, water resource engineering, then hydraulics, then irrigation, then transportation, then environmental engineering, then town planning. These are the various branches of civil engineering. Okay, civil engineering is a wide branch. Okay, you will find different aspects in civil engineering. For example, surveying means identifying the ground points. Okay, then construction technology, improvement in technology, then structure, then geotechnical, then water resource. There are very broad disciplines of civil engineering. Okay, there are various aspects of civil engineering. We will first see surveying. Okay, but before that, let me tell you the scope of civil engineering. First, the main scope of civil engineering, as we have discussed, planning, design, nothing different than that. The main scope we have already discussed, that is planning, design, estimating, then supervising construction, execution, maintenance. Okay, we have already discussed these things. So let's move to the disciplines of civil engineering. As I told you, the first is surveying. Okay, broad disciplines of civil engineering. Okay, the branches of civil engineering. Civil engineering consists of various branches. Okay, not only the building construction involved in civil engineering. There are various things such as surveying, then geotechnical, water resource, hydraulics, irrigation, transportation, environmental engineering. Okay, then town planning. There are various aspects. Okay, so first we will see surveying. See, surveying means identifying the ground points with respect to a particular point. Okay, surveying is the science of map making. Okay, might have seen the different maps. Okay, the house map. Okay, the different geographical maps. These are all constructed by using surveying. Okay, these maps are made up by using surveying techniques. For example, suppose this man is taking the different location of these points. Okay, if you consider this point, you mark this with the, for example, this point. Okay, this point, consider this as a reference point. This is considered as a reference point. Okay, and there are a lot of points you have to identify. So for example, this point. Okay, this point. So what is surveying? Surveying is identifying the relative position of any point. Relative position means with respect to this point. That is why it is called as a relative position. For example, you have to identify the level of these points. Okay, with respect to this. So the height of, suppose this point is suppose at an elevation of, suppose consider it as a zero elevation. Okay, so the height may be in minus, it may be in plus. Okay, with respect to this point. So this is called surveying. Then also the horizontal distance. Okay, the distance between these two points. Okay, this is called surveying. Okay, height also, the verticality between these 2 points. Okay, the vertical height between this and this point. For example, like this, the vertical height between this point, and also the horizontal distance. So marking these different points on the field with respect to a particular point, that is called a survey. Okay, so with the help of a particular point, you have to mark the different points on field. Then also you will identify the horizontal distance as well as the vertical distance of that point. That is called as surveying. Okay, that is called as surveying. There is a dedicated chapter on surveying. We will study in detail. Just for an introduction, I am just giving you an introduction about the surveying. Okay, surveying is the science of mapping. By using these techniques also, the map usually prepares. Then to start development activity in an area, the relative position of various objects in the horizontal and vertical direction are required. As I told you, the horizontal and also the vertical height, okay, vertical directions and vertical distance with respect to a particular point. This is approved by surveying the area. This is done by surveying the whole area. Okay. So for by using this instrument, for example, this is an instrument called total station or auto level, whatever the instruments are used, this instrument directly gives the horizontal distance as well as the vertical distance. Now this instrument should be set on a particular height, a standard height, and this is called as a staff. Okay. By identifying there is a readings on this vertical staff, okay, we will bisect by using the instrument these readings. Okay, again I'll mark this like this. We will we will identify the readings by doing calculations. We will find out the vertical distance. Okay, this is the this process takes some time. Okay, by identifying this you will identify the vertical as well as horizontal distance. Okay, by using this instrument. Okay, so a dedicated chapter is there for surveying. We will study in detail. Okay. Okay, so surveying should be performed before starting any activity. Okay, if you have to construct roads, bridges, you have to mark the different points on grounds just to identify the locations of those points. What is the height, what is the ground level of that particular site. To identify those things you have to perform surveying. Without surveying we cannot start any activity. Okay, so let's move. So object of surveying is to prepare map to show relative positions of the object on the surface of earth, then to establish boundaries. For example, any boundaries can be established by using surveying. Okay, to select a suitable site for engineering project. For example, if you are doing a survey of particular area, you will identify the levels of ground. Okay, so you will select those points which are almost in the similar level. Okay, which is almost on the similar level, so the cost of cutting and filling is reduced. Okay, the ground level is almost same, so the road and railway work, whatever site you have to select, that is performed by using surveying techniques. Let's move to the next. That is a building material, and I told you everything about this building material. If you remember in last lecture, bricks, cement, concrete, sand, reinforcement glass, plastic, wood, tiles. Okay, these are the building materials. Okay, and I told you that concrete and reinforcement both are used for any construction of beams, columns, slab, because these two are the very similar in case of coefficient of thermal expansion. The coefficient of thermal expansion of concrete and reinforcement are almost same, and also concrete is very good in compression and steel is very good in tension. Okay, we have discussed these things before in previous lecture. Okay, next is the construction technology. I told you that the construction technology, if you remember the first passage which we studied earlier, and I told you that right from the stone ages the development activity is continuously going on. Okay, there are various new techniques coming. Okay, there are various new techniques are coming. For example, before, in case of stone ages, people use different materials, and today the materials also improve. That is nothing but the construction technology. And as land cost is going up, there is a demand for tall structures in urban area, while in rural area need is for low cost construction. And uh, as you see, in today's time the cost of land is increasing. Okay, the cost of land is increasing. That's why people are constructing tall structures, because in low in you can say in a small area we can construct a large building, so that more people, more rooms can be accommodated. So the construction activity is also improving. High rise buildings are constructing in today's time. That is nothing but construction technology. Next is structural engineering, and I told you everything about this. Okay, the construction technology, that is structural engineering. Okay, I'll repeat again that this is the slab. Okay, these are the beams, then columns. So what happens in structural engineering? A structural engineer design these elements. Remember that design part, the size of beam, column, I told you. So the work of structural engineer. Structure is a branch. If you completed your BTech or BE, you can do MTech, masters in structural engineering. Okay, so you will get a tag of structural engineer. The work of structural engineer is to construct beam, is to design beam, columns, footing, every element of building. Okay, that is the work of structural element. What he will do? He will design the size. He will design the beams, columns. Design means providing proper size, proper steel reinforcement. Okay, that is the work of structural engineer, and we have discussed this in previous lecture also. So, for example, there are various loads coming. For example, the dead load. Dead load means the self weight of these elements. After that, the live load. Live load means the load of people, furniture. Okay. And after that, there is earthquake load. There is a wind load. There are a lot of loads are there. So he will consider all those loads before designing. Okay. So see here, load is acting on a structure is ultimately transferred to the ground. I told you this before, how the load is transferred. In doing so, various components of structure are subjected to internal stresses. Stresses means the load. Okay, load coming on a particular element will create stress. Okay, assessing the internal stresses in the component of structure is known as structural analysis, and finding the suitable size of the structural component is known as design structure. Okay, we have discussed this before, and previously in the design aspect I told you these things. A civil engineer has not only to give a safe structure, but he has to give economical section. Remember, I told you this, that there is a very two important things of civil engineer has to do. The two most important thing, he has to design safe as well as economical structure. Okay, so that is the work of structural engineer. After that, geotechnical engineering. The next aspect in civil engineering is geotechnical engineering. Now, geotechnical basically deals in the soil work. Okay, in the soil. For example, in you take anything, road, bridges, houses, everything should be rest on the ground. Okay, so whatever happening below the ground, that is the duty of a geotechnical engineer is to identify the type of soil over which a structure is to stand. Okay, so he has to identify whether the soil is soft, hard, whether the rock is there, everything he has to identify. Okay, for example, if you see this house example, this is the footing, this is the foundation, just an example. It looks like a good soil, it looks like a bad soil, that's why it is going down, because the soil is soft, load is coming heavy. So different measures should be taken on these particular things. Okay, for example, if you compare these footings, this looks like a good footing, this looks like a failure footing, that's why it is going like this. So in those situations, this ground is properly filled with different material. For example, gravel should be added here, so that we can avoid this failure. Okay, so the duty of a geotechnical engineer is to identify the type of soil over which the house is to be constructed. Soil property changes from place to place. As you all know that in Nagpur there is a different soil, in Mumbai there is a different soil. Okay, the load from the structure is to be safely transferred to the soil. Remember, the load is ultimately transferred to the soil. They are carrying by the different elements, but they are ultimately transferring to the ground. That's why the soil should be strong. Soil should be very strong, because ultimately the load should be transferred to the soil. That's why the bearing capacity of the soil. The soil has bearing capacity. Okay, the capacity of bearing those heavy loads, that is called as bearing capacity. For this, safe bearing capacity of the soil should be properly assessed. There are various techniques, various methods are used, which is used to identify the bearing capacity of soil. How much the load the soil can be bear. Okay, soil can bear how much loads. There, these are identified by the different methods. There are plate load tests. There are standard penetration tests. There are various tests. Tests are used. So after identifying the properties or safe bearing property or anything of the soil, the next step is the construction. Okay, that is very important. You have to identify the type of soil. because on the basis of this only you will provide the floor. You can identify how much floor you can construct. Okay, what are the precautions should be taken? These are the things you have to plan after assessing the property of the soil. This branch of study in engineering is called geotechnical. That's why it is called as geotechnical engineering. Okay. Okay. So the next aspect is hydraulics. Okay. Hydraulics. See, water is an important need for all the living beings. So, study of mechanics of water and its flow characteristics is another important field in civil engineering, and it is known as hydraulics. First of all, hydro means water. Okay. Then hydraulic structure. If I told you what is hydraulic structure, if I ask you what is hydraulic structure, what would you say? You will say dams. Okay. The best example of hydraulic structure is dam. So dam is carrying the load or the force by which, by water. Okay. That's why hydraulics is totally based on the study of water and also the design of pipelines. Okay. The pipeline designs are also carried by the civil engineer. So in those pipelines, the pressure of water is identified. Okay, that's different characteristics of water. The flow characteristics of water is very important. That's why in the field of civil engineering, this hydraulics is very important. Okay, for example, suppose this is a dam portion. The dam carries the weight of this water. The force by this force is usually carried by the water. Okay, water strikes on the walls of dams. Okay, so the construction of dams is planning of this dam is totally based on the water force. Okay, that's why the characteristics of water is very important. You have to identify the pressure, force, okay, the viscosity, everything, every point on of water. You have to identify this thing. That's why hydraulics is one of the very important branch of civil engineering. It is completely different, but it is also very important. Okay, that is called as hydraulics. Next is water resource engineering or irrigation engineering. So this, as you can see the image of dam here. So the construction of these dams, these are carried by the civil engineer. Why the dams are constructed? For irrigation purpose, for storing of water. The water is dam is basically the water storage tanks, for example, which is used for water storing, and then the water is slowly transfer from the down upstream to downstream. Okay, then this water is used for the irrigation purpose, for agricultural purpose. Water is to be supplied to agricultural field and for drinking purpose, and suitable water resources are to be identified and water is to be stored. You have to identify whether you have, in which place you will construct dam. Okay, how will you supply the water to the irrigation fields? These are all the works of civil engineering. Identifying, planning and building water retaining structures like tanks, dams, carrying stored water to the field is known as water resources and irrigation engineering. Okay, these carrying water from one place to another place is also work of a civil engineer. Different types of structures are constructed for transferring water from one place to another place, for storing water. Okay, so these are the part of hydraulic as well as water resource engineering. So this is also the work of civil engineer. See, I am just giving you an example or introduction of this branch. Okay, we will study this branch in detail. Okay, I'm just giving you a brief introduction of this branch. Okay, if you don't understand these things, don't worry, we will study in detail. Okay, we will study in detail. I'm just giving you a brief introduction. So the next is transportation engineering. As you all know, the construction of road, bridges, railways comes under the transportation engineering. Okay, so to provide a road strength, full of strength road, to provide a strong road, that is a duty of civil engineer. And also traffic engineering also comes under civil engineering. Okay, providing good and economical road is an important duty of civil engineer. Okay, railway is another important long way transport facility. There is a need of airport, harbors also. Okay, remember airport, harbors, these are constructed by civil engineers. For proper planning of these transportation facilities, carrying out traffic survey, design, construction, maintenance of road, bridges, railways, harbors, and airport is known as transportation engineering. The construction of railway station, airport, harbor, everything, anything you can take. That is the duty of civil engineers to construct road, railway, okay, everything. And also remember traffic engineering also comes under civil engineering part. Okay, as I told you, there is a structural engineering. After you can do structures engineering after completing your btech in civil. Similarly, you can choose transportation also. Okay, and I have, for example, if you consider me, I have also uh, done my mtech in transportation engineering. Okay, transportation engineering consists of design as well as, for example, if you consider road, construction of road is also the duty of civil engineer also, as well as maintaining the proper traffic on that particular road also comes under civil engineering part. Okay, so these are all comes under transportation. Okay, providing good and economical road is a duty of civil engineering. Similar words are here, just image is changed. Signaling also, signaling also, providing proper signal on intersection, that is also a duty of transportation engineering. Next is environmental engineering. After hearing this word, you might have think that environmental basically deals with the air pollution things. Okay, but this is not the case. In environmental engineering, the most important thing is the water distribution system. The water which you drink is first purified in the water treatment plant. The water treatment plant is constructed and maintained by the civil engineering or civil engineers also. Okay, so environmental engineering consists of various things. For example, water treatment plant, okay, then water wastewater, then solid waste, and also air pollution and noise pollution also. Okay, so proper distribution of water to rural areas, towns, cities, and disposal of wastewater, solid waste are another field of civil engineering. Environmental engineering, while tackling all these problems, provide healthy environment to public. Okay, so for example, suppose I'm just giving you an example again. Suppose suppose this is the water treatment plant. This arrow, this is the treatment plant, and this is the particular city. You have to treat water here, okay, and then supply this water through various pipelines. Again, remember hydraulics, water is transferring, so you have to understand all the characteristics of flowing characteristics of water. Okay, that's why here again hydraulics is very important. So transferring water from this treatment plant to the city is also the work of civil engineer, which comes under environmental engineering, which is the part of another branch of civil engineering. Okay, so environmental engineering basically deals with the water distribution and wastewater. For example, after they are also supplying the water, and also they are also disposing or doing the disposal of wastewater. For example, the wastewater which is coming from a particular houses is carried and transferred, okay, by the process of environmental engineering. Okay, so the process right from the transferring the water to again disposal, then solid waste disposal, these all comes under the environmental engineering part. Okay, let's see the next thing, town planning. See, town planning is nothing but, for example, if you consider a new area, okay, so nmc nit, if you consider nagpur city, then nagpur improvement trust or nagpur municipal corporation usually plan a particular area. They plan that whether the road should be going from which direction. Okay, there should be a playing ground, there should be different activities, or should be there, the area should look aesthetically good. So these comes under the town planning. Okay, so these are also done by the civil engineer. Aesthetically good structures are required. Towns and cities are to be planned properly. The field of civil engineering has grown considerably and has become a course of separate from civil engineering. There is another subject, that is town planning. This is different from civil engineering. You have to plan the particular large area. Okay, for example, a large area you have to plan what should be the amenities should be provided. For example, playing ground, swimming pool, whatever. These are all plans under the town planning scheme. Okay, so this is also the part of civil engineering. Now people have separated this from the civil engineering, but it also comes under the civil engineering. Okay, so I hope you have understood everything which I taught you today. And if you have any query or any question, you can ask me. And in next lecture we will see what is the role of civil engineer in infrastructure development. Also, what is the basic duty of civil engineer. Okay, so thank you so much for listening this, and we will meet in next lecture. Okay, thank you so much.